I'm Ahalya. Today I'm going to discuss about the continuation of the last class, primary particles or base or fundamental particles. Okay, fundamental particles. In this we finished electron, proton. Okay, and now we are going to discuss about neutron. Okay, neutron. Neutron. I already discussed this about uh, atom having nucleus and having positive charge and present at the center of the atom and having both protons and neutrons. Okay, neutrons means neutrons which are present inside the nucleus. Okay, inside the nucleus. And in 1932 Curie couples discovered these neutrons and experimentally discovered by James Chadwick. Okay, and it having no charge means neutral. Okay, and the low energy neutrons called as thermal neutrons. Okay, these low energy neutrons which are required for the nuclear fission reactions. Okay, means these low energy neutrons which are bombarding with these unstable and heavy mass of the nuclei. Okay, this is called nuclear fission reactions. Okay, that is nuclear fission reactions. For these, the low energy neutrons are required. The lifespan of nuclei outside the nucleus. The lifespan of actually this neutron always present inside the nucleus along with protons with a neutral state. Okay, if it present inside, then its lifespan is only 15 minutes. After that it will split. Okay, it will split into particles. Okay, and mass of neutrons. Okay, mass of neutrons which is approximately equal to mass of the protons. Here the mass of the protons is 1.0078 AMU or atomic mass unit. Okay, and or 1.67 into 10 to the power of minus 27 kgs or 2000 into mass of the electron. Okay, or these mass of the electron each expressed like m is equal to 1 by 2000 into mass of the proton. Okay, the mass of the neutron, which is approximately equal to the mass of the protons. Okay, and the mass of the proton, which expressed in three in atomic mass units and kgs, and along with this mass of the electron. Okay, I'm going to simplify this topic with a small table which are differentiating electron, proton and neutron. These primary particles, which is three types: electron, proton and neutron. And first, in 1897 electron discovered, and protons, okay, in 1920, and neutrons 1932. Okay, 1932. For remembering, just between these 2 years 23 years, between these 2 years 12 years. Okay, 23 and 12, or 2 and 1 3. Okay, just remember. So just easy remembering, as I said that, some small logic. Okay, and by Plucker discovered. Okay, here Goldstein discovered, and here Curie couple discovered, and experimentally discovered by J.J. Thomson, Rutherford, and James Chadwick. Okay, James Chadwick. And charge of electron is a negative charge. It's positive. It's neutral state. Okay, and mass of the electron is equal to 1/2000 into mass of the protons, or here mass of the proton is equal to 2000 into mass of the electron. Here mass of the neutron is approximately equal to mass of the proton. Okay, and presence of the electrons outside the nucleus, and here inside, here also inside. If present in outside, within 15 minutes it will split into another particles. Okay, another particles. It will not stable. It only stable inside the nucleus. Okay, and the value is 1.6 into 10 to the power of minus 19 coulombs, and by millicon. And here the value is 1.6 into 10 to the power of minus 19 coulombs. Okay, here no value. Okay, these are the mainly you have to remember about primary particles, or base, or fundamental particles. Okay, by this way you can easily remember this topic. Okay, next, quantum numbers. What is quantum numbers? Why we have to discuss these quantum numbers? These quantum numbers is a value that is used when describing the energy levels available to atoms and molecules. Okay, I simplified in diagrammatical. Okay, I already discussed the atom having the nucleus and it present at the center of the atom and having positive protons and a neutron, and okay, it having energy levels, in each energy level or a stationary energy level or stationary orbital or shell having electrons, which indicates K, L, M, and then okay, K, L, and M, N. Okay, and having 2 electrons, 8 electrons, 18 electrons, 32 electrons. Okay, like this. And these 2 electrons filled in s orbital, these 2 in sp, and these in spg, and these electrons in sp, d, and f. Already I have discussed this in earlier class. Okay, these are the energy levels. Okay, these are the energy levels. For this description, for this detailed description, we have to study the quantum numbers. Okay, and these quantum numbers are of 4 types, which is first quantum number is principal quantum number, principal quantum number. Okay, principal quantum number. And second one is azimuthal quantum number, okay. Third one is magnetic quantum number, okay. Fourth one is spin quantum number, okay. All these are okay. Here 4 types of quantum numbers. First one is principal quantum number, second one is azimuthal quantum number, third one is magnetic quantum number, fourth one is spin quantum number. These principal quantum number indicates by n, small n, and azimuthal quantum number indicates by small l, and here magnetic quantum number indicates by small m, and s spin by small s. Okay, and explained by Niels Bohr. Who said the Niels Bohr's atomic model. You remember that? Okay. Here he explained principal quantum number, and azimuthal quantum number explained by Sommerfeld. And here magnetic quantum number explained by Rounday, and spin quantum number explained by Uhlenbeck and Gaudsmit. Okay, Niels Bohr explained principal quantum number, Sommerfeld explains azimuthal quantum number, Rounday explained magnetic quantum number, Uhlenbeck and Gaudsmit explained spin quantum numbers. Okay, this principal quantum number, which explains the energy and size of the orbit or energy levels. Okay, orbit or energy levels or shell. Okay, here this azimuthal quantum number explains the shape of orbitals. I already said that orbitals are subshells, which is S, P, D, and F. These shapes means S having spherical shape, P having dumbbell shape, D having double dumbbell shape, F having four folded double dumbbell shape. Okay, four folded double dumbbell shape. Okay, and here in this L, okay, L value represents 0 and azimuthal quantum number P value, L values here 0, P having 1 and D is 2 and D is 3. Okay, if L value is 0, that is S, which is spherical shape, and if L value is 1, that is P, that means double dumbbell shape. Okay, and D means which is L is 2, that means D. If L is 3, that means F. Okay, L values 0, P having 1, D is 2 and 3. Okay, okay, and here it explains the orbitals orientations. Okay, orbital orientation, which is SPD orientations. Here magnetic quantum number explains. Okay, this magnetic quantum number M depends on L value, that means L value which depends on M value, which depends on L value, that is M equal to 2L plus 1 formula. According to this formula, magnetic quantum number depends on azimuthal quantum number, and this if L value is equal to 1, then M equal to 2 into 1 plus 1, that is 2 plus 1, that is 3. That means L value equal to 1, that is M is 3 value. Okay, L is 2, that is M equal to 5, like that. L equal to 3, that is M equal to 7, like that. M value depends on L value. Okay, okay, okay. Here spin quantum number explains the spin of electrons which are moving outside the nucleus in atoms or molecules. Okay, and here principal quantum numbers always on integer value, never ever 0 or negative value. Okay, if here L value is greater than 0 or equal to, or L less than or equal to n minus 1. Okay, that means minus this value between L minus L2 plus L, that is if L value greater than or equal to 0 or L value less than or equal to n minus 1. N minus 1 means, n means here principal quantum number. Okay, here and magnetic value which depends on L value, and here S value which is half integer. Okay, half integer value, and this is half spin up. Okay, sorry, it indicates like this, called as spin up or spin down. Okay, it always expressed in half integer values. Okay, these are about the quantum numbers which are 4 types: principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. principal quantum number explained by Niels Bohr, and he explained about the orbitals, energy and size of the orbitals or energy levels or the shells. Okay, and its value always in integer value, which are never ever 0 or minus values. Okay, and Esmittel quantum number explained by Sommerfeld, and he explained the shape of the orbitals or subshells, that means S, P, D and F, and S value, S is spherical shape and P is dumbbell shape and D is double dumbbell and F is four folded. Okay, and if L value is 0, 1, 0, that is S, and if L value is 1, that is P, and if L value is 2, that is D, and if L value is 3, that is F. Okay, we have to remember these basics, and these will useful in Euler's diagram. Okay, and if this L value which is greater than or equal to 0, okay, and L value which is less than or equal to n minus 1, this L value which is in between only this minus L2 plus L. Okay, that is minus L2 plus L means greater or equal to 0 or less than or equal to n minus 1 value only. Okay, magnetic quantum numbers, which explained by Landry and orbitals orientation. He explained orbitals orientation, and this m value always depends on L value, that means m is equal to 2L plus 1, which if L value is 1, that is m is equal to 3, that like that m value which depends on Esmittel quantum number. Okay, and spin quantum number explained by Uhlenbeck and Goudsmit, and he explained it, the spin of the electrons in the atom or outside the nucleus or molecule. Okay, and he explained and it expressed in half integer values, that is half up and half down, that is spin up and spin down. Okay.